But the point of that activity was to show you that deductive reasoning is different than inductive reasoning in that it uses facts, rules, definitions, properties, or rules to reach some logical conclusion instead of inductive reasoning, which uses an example. Okay? Inductive reasoning just says, here's an example. Here, for example, here's a pattern. What's the next item? Okay. There's two theorems on this sheet. One's called Law of Detachment. One's called Law of Syllogism. Okay? We're going to talk about each of these and how they prove stuff to be true. So the first one, it's on your sheet there. It's called Law of Detachment. It says if a statement P then Q is true, and P is true, then Q must be true. Okay, again, remember this arrow means then. If statement P then Q is true, and P is true, therefore Q must be true. So that's going to make more sense when we see it in an example here. Okay, but this is called the Law of Detachment. You don't have to memorize that because it's on your postulate sheet. So for example, if you multiply two odd numbers, if I call that statement P, if you multiply two odd numbers, then the product is an odd number. So 17 and 29 are odd numbers. Therefore, what would be this statement by the law of detachment? So if you multiply two odd numbers, then the product is an odd number. 17 and 29 are odd numbers. Therefore, the product of 17 and 29 is an odd number. Right? This follows the law of detachment. It says if P, then Q. P is true, therefore Q must be true. Right? If P, then Q. P is true, so that follows from P, therefore it must follow from Q. Remember, these are statements like that statement P, we call that statement Q. Law of detachment. So my logical conclusion would here would be the product of 17 and 29 is an odd number. I got this from this statement up above. We're going to do a lot of examples with these today. Let's look at a couple more. Okay. How about this one? If you pass a test, then you got at least a D. Bob passed the test, therefore what? Therefore Bob got at least a D, right? So let me go back here. So this follows from the law of detachment. If P, then Q. Bob followed P, therefore Bob must have followed Q. If you pass a test, you got at least a D. Bob passed the test, therefore he got at least a D. That's called law of detachment. Law of detachment. Okay? Now, the other one is called the law of syllogism. So, like the law of detachment uses two statements, P and Q. Okay? The difference is the law of detachment uses three statements. It says if P then Q, and if Q then R are true, then P then R is true. It's similar to the transitive property. Remember the transitive property says like if the first and second thing equal each other, and the second and third thing equal each other, then the first and third thing must equal each other. It's kind of similar but with statements here. If P then Q and Q then R are true, then P then R must be true. So let's look at an example of that. If it is raining, then there are clouds in the sky. If there are clouds in the sky, then it is dark outside. So what could be my logical conclusion here? This is almost like that string conditionals we did in class the other day, right? The law of syllogism says if P then Q. If Q then R, therefore if P then R. What would P then R be here? Remember, if this was P, this was Q. This was Q, this was R. Therefore the law of detachment says P then R. Exactly. It would be if it is raining, then it is dark outside. So notice the difference is it uses three statements. P, Q, and R. Where law of detachment only uses two. If P then Q, if Q then R, therefore P then R. I think the best way to go through is to underline them and make sure you know which statement's which. And you can see if a logical conclusion follows. Good, so that would be the logical conclusion. If it is raining, then it is dark outside. Let's look at another one. If you do all the homework, you will get an A on the test. If you get an A on the test, you will pass the class. Therefore, exactly. If you do all your homework, then you will pass the class, right? If P, then Q. If Q, then R. Therefore, if P, then R. Okay? How about this one? Use the law of syllogism to determine whether a valid conclusion can be reached. If Sue attends a dance, she will go with Mark. If Sue goes with Mark, Donna will go with Albert. Therefore, If Sue attends a dance, Donna will go with Albert. Right? Yeah. You know, I like how it says this is a real world example. You know, like you're concerned about people going to dance and Albert's date. Right? Real life. Yeah. How about this one? If Mel and his date eat at the steakhouse before going to the prom, then they will miss the senior march. The Peddler Steakhouse stays open till 10, therefore, doesn't follow, right? That's not the law of syllogism. If P, then Q, and then it gives me a totally different statement, right? So I would say this one, there's no valid conclusion. I can't say what's happening next. They could miss the march, or they could miss the close of this. I don't know by these statements. The conclusion of each statement is not used as hypothesis of the other. I didn't say if this, then that. If that, then something else. Okay. How about this one? If I am nobody, nobody is perfect, therefore I'm perfect, right? How about this one? Stealing refrigerators is hard work. Hard work is good for you. Therefore stealing refrigerators is good for you. Good. How about this? A tuna sandwich is better than nothing. Nothing is better than unlimited wealth, health, and happiness. Therefore, a tuna sandwich is better than unlimited wealth, health, and happiness, right? Are we seeing how I'm about to prove KU is the best football team in the country? I'm about to prove that. Okay. All right. So we're not going to do this. And I'm going to come back to these puzzles because we got a short class today. We did the 2 red cards, 2 black cards. Okay. I want to look at these deductive reasoning puzzles real quick. Very good. That one is syllogism, right? Syllogism says, if P, then Q. If Q, then R. Therefore, if P, then R. That's syllogism.
What's detachment again?
Detachment is when you have 3 statements. So if you pass the test, then you got at least a D. Bob passed the test, therefore Bob got at least a D. Let's look at another one. If a polygon is a triangle, then the sum of the inside angles is 180. GHI is a triangle, therefore the sum of the inside angles of GHI is 180. Detachment, syllogism, invalid. Now what's detachment? If P, then Q. This follows from P, therefore it must follow from Q. That's detachment. Good. How about this one? If your alarm clock goes off in the morning, then you will get out of bed. If you ride a bus, then you go to work. Not valid. Doesn't follow. Not syllogism, not neither. Not valid. Okay. This one we don't need to go over because we've proved we can do that. This one is just, if you add the squares of 2 sides of a triangle equal to the third side, then it's a right triangle. 2 sides squared added to the third side equals the third side squared, therefore it's a right triangle. This one's detachment. Okay. If Ling wants to participate in wrestling, he will have to meet an extra 3 times a week to practice. If he adds anything to his weekly schedule, he cannot take karate. If he wants to participate in wrestling, he cannot take karate. Okay? This one, if he wants to participate in wrestling, he will have to meet an extra 3 times a week. That's Q. If Q, then R. That one would have been syllogism. Okay? All right, that's what we need to know about that.